Solving quadratics graphically. The learning objectives. By the end of this section, you should be able to identify the significant points of a quadratic graph, solve quadratic equations from their graph, solve quadratic equations by intersection. When answers are read from a graph, they will never be absolutely correct. Therefore, you must allow for slight differences between your answers and the ones given here. In short, when we're reading from a graph, it's always human error, it's always open to interpretation. You might see it slightly different than I do. So if your answers are slightly out, they're correct, but incorrect. The graph of a quadratic equation has 4 significant points. First one is the roots or the solutions. These are the x values where the graph crosses the x-axis. So here are the 2 roots or the solutions. This graph has 2 roots or solutions. Not all quadratics do. Some quadratics will only touch the x-axis once, the turning point. These graphs will only have one solution. If the graph does not cross the x-axis, it will have no real solutions. And we will only be dealing with real solutions here. The next significant point is the vertex or the turning point. This is identified by using the x and y coordinates. If we're asked to identify the vertex, we give the coordinates of the turning point of that graph. So we give the x coordinate and the y coordinate, which will be read off the x and y axes. For U-shaped graph, the turning point is called the minima, and for an N-shaped graph, it is called the maxima. So the minimum value it can take and the maximum value it can take. The y-intercept, the next significant point, which is here. The y-intercept will always be when x equals 0. Therefore, for any quadratic, ax squared plus bx plus c, the y-intercept will always be at the point 0, c. So that the value of c in the quadratic equation gives us the y-intercept in a similar way it did when we were looking at linear equations. If given the graph, or by sketching it, we can find estimates for each of the significant points. And again, estimates, these are not absolute accurate, they're what we can see from the graph. And again, when we plot it, if we plot it by hand, it's never going to be 100% accurate anyway. You have to just be aware your answers are not going to be perfect in here, but it gives us an idea of what we're looking for. This is the graph of a quadratic equation. Give an estimate for the coordinates of the vertex of the graph. We look down at the bottom of the graph and roughly 0.4 minus 2.1. A common mistake would be to give the y value as minus 2 because it's nearly there. But it isn't. It definitely isn't on 2. If it isn't exactly on the line, don't say it is, because then you're definitely wrong. Make the y-intercept. What's the point there? So it's y equals minus 1.9. And again, some people try to go to 2 or 3 decimal places. On a grid like this, it's just impossible. Don't go any more than that. You can only be as accurate as a scale on the graphs plotted on. So don't try and be overly precise with it. It's unrealistic to think you can go any more than that. Give estimates for the roots of the equation. Again, we look at there, where does it cross the x-axis? There are 2 points. We've got x as minus 0.9 and x equals 1.6. So if you've got the worksheet, use that. It'll be a lot easier. If not, you'll have to do it on the screen, which not going to be the easiest thing. However, it'll give you the idea of what we're looking for. So what I'd like you to do is pause the video now, either work through it on the screen, or even better still, use the worksheet. Once you've done that, come back and check the answers. So for the top graph, question 1, the coordinates for the turning point of the graph is 2 minus 2. The roots of the equation, we have x equals 0.6, x equals 3.4. And the coordinates of the y-intercept, we have 0, 2. And for the lower graph, the coordinate of the vertex, which in this case is a maxima, is minus 1, 3. The roots of the equation, x is minus 2.8 and x is 0.8. And finally, the coordinate of the y-intercept, we have 0, 2. So, given the graph of y equals x squared plus 3x plus 1, solve the equation x squared plus 3x plus 1 equals 0. What it's asking for is, when will this graph, when will the output be 0? And that is these 2 points here. It is the solution to the graph, or solutions to the equation. X equals minus 2.6 and x equals minus 0.4. Use the graph to estimate solutions to x squared plus 3x plus 1 equals 3. To do this, we find the x values that will generate a y value of 3. And what this means is, what would be the x input to generate a y output of 3? Well, there's 3 on the y-axis. We either draw the line y equals 3, or just put a line across from it. And what are the corresponding x values here? Yeah, x equals minus 3.6 and x equals minus 0.6. So solving quadratics graphically again. Like before, if you've got the worksheet, use that. If not, you're going to have to work off the screen. So give these a go. Question 5, it's more the wording that's a different question, but just give it a go. Once you've done it, come back, play the video again, and we'll go through the answers. So question 1, x equals minus 3.5 and x equals 1.5. Question 2, x equals 3.8 and x equals 1.8. 3, x equals minus 2.4 and x equals 0.4. Question 4, we have x equals minus 4.5 and x equals 2.5. Question 5, it's the same question, it's worded differently. It is x equals minus 4.2 and x equals 2.2. Give coordinates to the vertex of the graph, minus 1, minus 6. If your only answers are really wildly out of that, go back, look at them, look a bit more carefully, see where you went wrong. This is a graph of y equals x squared minus 4x minus 1. Use this to find solutions to x squared minus 4x minus 1 equals x minus 3. To do this, we draw the line y equals x minus 3. What we have here basically are two graphs. One at the left side of the equation, which is x squared minus 4x minus 1. And the blue one is the right side of the equation, x minus 3. Where the two graphs cross is the only point where those two graphs will have the same solution. So what we're looking for is the x values here. There's one of them. There's the other one. And it gives us values x equals 0.4 and x equals 4.5. So if you were given the graph of y equals x squared minus 6x plus 4, what are the straight lines you would need to draw to solve these? So you're not being asked to actually find the solutions, it's just confirming that we know what lines we're drawing. So the first three are fairly straightforward. The last two, many to think about. So have a go at that, pause the video. Once you think you've got it, come back and we'll get the answers. So question 1, y equals 4. Question 2, y equals x plus 2. Question 3, we had y equals 2x minus 3. For the last two, if you looked at them, they were slightly different. What you had to do, in effect, was change the left side so it was the graph that you had given. What would you have had to do to it? So because that the c value there was plus 6 and the original was plus 4, you had to minus 2 from both sides. So that would mean we need to line y equals minus 2. For the last one, the c value here was plus 2, when in the original graph it was plus 4. So we have plus 2 to each side, which would give us the line y equals plus 2 or y equals 2. So hopefully you got them right. If you didn't, look at them. You have to understand why you got them wrong before we can do the next exercise. If you haven't got it, spend a bit of time looking at them, see where you went wrong. Once you're ready, move on. So, given a graph x squared minus 2x minus 3 equals 0, and use them to follow to solve, rather than find the solutions of the following equations. So again, use the worksheet if you've got it, if you manage to print it off. If not, use the on the screen one. It's not going to be as accurate, but you can still get the idea. So go through that, pause the video now, do that. Once you've done it, come back and we'll check the answers. Right, well, hopefully we got through them. The first one, that is our line, and the solutions are x equals minus 0.6 and x equals 3.6. Question 2, that's what your line should look like, and gave you values of x equals 0.2 and x equals 3.8. Question 3, graph your line you plotted should look like that, and is x equals minus 1.8 and x equals 1.8. Sorry, x equals minus 1.8 and x equals 1.8. And for question 4, there's our line. We have the two values x equals minus 0.7 and x equals 1.7. Right, hopefully you found that useful. It is going to be tricky learning by video, but we just got to do the best we can. Hopefully you got on all right with it. If you didn't get on too well, go back, watch it again and go through the